Friends, today let us do some problems on conditional probability. So first let us try to understand the concept of conditional probability, and then we expand over it and do some problems on conditional probability. So here we go. Now, sometimes it so happens that probability of a particular event depends on whether another event has occurred or not. Say another event is there B, and the event A's probability is dependent on the occurrence or non-occurrence of B. If B occurs, then it is of one type. If B doesn't occur, then the probability of A is different. A simple example in this case is that, like carrying an umbrella. Now, your probability of carrying an umbrella, suppose some people carries an umbrella, it becomes an habit. Whether it's sunny, whether it's rainy, whether it's cloudy or windy, they always carry an umbrella. But living apart, a natural, in normal sense, when we carry an umbrella, like if there is a chance of rain. So what happens? The chance that you carry an umbrella, let that be an event, that a person carries an umbrella. Let A be an event that a person carries an umbrella. Now B be the event that the day is cloudy. Now what happens? The chance of this probability of the event A, this is dependent on B. It increases if the day is cloudy. If B is cloudy, that means that is, if B happens, then probability of A increases. But if B doesn't happen, then probability of A shows a decrease. In other words, these decreases if B doesn't happen. B doesn't happen means B dash. Or B bar. So that means B bar actually comes into act if the event doesn't happen. So in that case, the probability of A is influenced by the occurrence or non-occurrence of B. In unison, we call it as A given B. That means we are interested in computing the probability of A when it is known that B has already occurred. That means we already know that B is cloudy. In that case, what is the probability of A? That is the thing of interest here. We will see subsequently some business examples of how A is influenced by B, some real examples on that, and we will also solve the problems of probability. So let us go to the next slide. So here we get the formula. If you remember, earlier we worked on a formula that probability of A intersection B, that means probability of A and B happening together, which we also called as probability of AB. This is equal to probability of A into probability of B, but there is a condition that this can be obtained, or this formula can be obtained if A and B are independent events. A and B are independent events. Independent of each other. But if it is not the situation, then we have this formula. Probability of AB is probability of A multiplied by probability of B when it is known that A has already occurred. Or we can take the reverse. Probability of B when multiplied by probability of A when it is known that B has already occurred. So this is the two way. You can see if in case A is not influencing B, then what happens? If A is not influencing B, then probability of B given A is equal to probability of B. And in that case, what happens? You see in this formula, this becomes equal to probability of B. That means we reach the formula that we have written in the right side. That means when A events are independent, from this formula itself, we can go back to the multiplicative law under independence. But sometimes you see out of A, B may influence A may influence B, or both may influence each other. Okay. For example, suppose in case of carrying an umbrella and rainfall, the rain is influencing your probability of carrying an umbrella, but not the reverse. That if you carry an umbrella, then it will rain or not. That means if B is the event of rain, A is the event you carry an umbrella, then A, that is the chance of carrying an umbrella, depends on the chance of rainfall, or depends on the event of rainfall, but not vice versa. But sometimes both may influence also. So both the formula are valid. So this is about the formula for conditional probability. Formula is very simple. There is no difficulty in the formula. Any doubt you have?
No, sir.
Okay. So let us go to the next problem here. Here what happens? A company has 4 varieties of health drink, A, B, C and D. Okay. 5 units of each are available in the stock. So I have one drink A, another drink B, another drink C, another drink D. Soft drinks I have in my store. Each of them are available 5 units. This is 5 units. This is 5 units. This is 5 units. So 5 units are. Now let us see what happens. If W be the event that out of the first 5 units sold in a day, 2 are from variety A. That means 2 of them out of 5 units sold, 2 of them are from variety A. So W is the event for that. So what is W event? W is that out of 5, 5, 2 are from A. Okay, that means out of 5, 2 are from A. Now let us see how many total number is there. 5 plus 5 plus 5 plus 5. Total in that particular store there are 20 such drinks. So I want to compute initially. I want to compute 5 W. Why? Because you are asked to. And what is B? Next event B. Let us have this B. B is the event that the 6th unit demanded is also from variety A. That means the 6th unit, 6th one is also from A. Okay, 6th unit. You are to continue compute the probability of B given W. What is the meaning of this? Meaning of this is that you already have the information that out of the 5 units demanded, 2 were from A. Okay, 2 of them were from A, because you are sitting in the store. One person is coming, he is collecting some drink, some bottles. Another person is coming, collecting some bottles. So ultimately 5 units are sold till this stage. Now when 5th unit is sold, you have seen that 2 of them were from A and 3 are from other. I am not interested. 3 are from other varieties, B, C, D, maybe a combination, maybe 2 from B, maybe 3 from B also. Any possibility, that is not my concern. Now what is the chance that the 6th one demanded will be also from A? Here what happens, if we look at only event P, then we are concerned with the sixth one. But actually when we compute the probability, the previous information is available with us. That out of 5 sold already, 2 are gone. So we have to compute this. Now look at the formula. As you know, this formula is given by W into, now what is the formula? You see, formula of this one, B intersection W, this is equal to probability of W into probability of B given W has already occurred. Okay, this is the formula. Just you may see the previous slide formula. From this I have written probability of AB equal to probability of A into probability of B given. Probability of BW equal to probability of W into probability of B given W. Okay, both ways it is possible. Now, what is this? Because I am interested in computing the probability of this. So I write that probability that the 6th unit is of A from A when it is known that already 2 of them are sold out of the 5. This is equal to probability of B intersection W and divided by probability of. That means I have to separately compute this and I have to separately compute this. Now try to understand what is the numerator. Numerator is that probability that what is W, that out of 5, 2 are from A. Okay, and what is B, that the 6th one is also from A. That means what what probability you want to compute, that out of 6, 3 are from A. Okay, this satisfies both B and W, you see, because this is telling that out of 5, 2 are from A. This is telling that 6th is from A. So if you combine, it means that out of 6, the 3 of them are from A. And what is your probability of W? It is also clear that out of 5, 2 are from A. That means we have 2 probabilities, one in the numerator, one in the denominator. Let us first compute the denominator one and then I will see. So what happens in the denominator? Let us assume the total number of cases. Here out of 5, 2 are from A. That means 5 of them are sold. Now from 20, 5 of them can be sold in how many ways? 25 of them can be sold in 20 5 ways. Okay, and then out of the 5 that are sold, two of them are from A. So that is 5C2. 5C2. So this is one probability. And let us look at this here. Out of 6, 3 of them are A. So from 26 things, how can you choose? So it is 20C6. And in the numerator, how many? It is like, what is that? That is out of 6, 3 of them are from A. So this is 6 is sold. So 6 C3. 6. So this is the probability. Now you just break the combination, and then so what you get here, you get 6 factorial, yeah, divided by 3 factorial into 3 factorial, whole thing divided by this is you get 20 factorial, then 6 factorial divided by 6 factorial into 14 factorial, whole thing divided by this is 5 factorial, this is 2 factorial, and this is 3 factorial. 5C2, that is 3 factorial, whole thing divided by, then this is 20 factorial, and this is 5 factorial, and then this is 20 minus 5 factorial. So this is 20 minus 5 is 15 factorial. So these things you have to compute a little bit, because many things get cancelled. You see this 20 factorial gets cancelled. Then this 3 factorial gets cancelled. So what remains, let us clean the screen a little bit to get some space. So this is equal to, so let us draw this first. So what all things remain in the numerator? You have then this okay, here we have 1 6 factorial, first one 6 factorial, then we have this 3 factorial. These 3 things remain. This goes up, so you have here 6 factorial, and here you have 14 factorial, and this 20 is already cancelled, so this is divided by 1. Okay. And here what I have 5 factorial by 2 factorial, and then this is multiplied by this 5 factorial goes here, 5 factorial, and then 15 factorial also comes up, and this is 1. So here what happens, 6 factorial, I can write 6 factorial as 6 into 5 factorial. Okay, this 6 factorial also I can write into 6 into 5 factorial. Okay, 5 factorial, and then let me write 14 factorial. Okay, divided by whole thing divided by, we have 3 factorial. Here we have this 5 factorial, I can write like this, 5 factorial into 5 factorial, and 15 factorial I can write 15 into 14 factorial, 14 factorial. So this is factorial is there, 14 factorial. So this 14 factorial, and in the numerator I have 2 factorial. Okay, fine. So these 14 factorial get cancelled. Then I have here 15, this 5 factorial gets cancelled, 5 factorial gets cancelled, 3 factorial I can write this as 3 into 2 factorial. So that way these 2 factorial and 2 factorial gets cancelled. So what remains in the numerator? Remains in the numerator 6 into 6, 36. 36 divided by 3. So I have 36 divided by 3 in the numerator. Okay. And in the denominator I have 15. I think other things are all cancelled. So 15. So this is 36 divided by 3 comes 45. So if you actually deduct it with 3, then you get this is 15, and this is, I think, 36 is 12. So once again it goes, so it is 4 by 5. So probability comes out to be 4 by 5. So this is the chance that that 6th unit demanded will be increasing very high. So since 2 is already demanded from A, and that information is available to you, so the next unit demanded will also be from A. That probability becomes very high, 80% chance is there. that the next unit demanded will be from category A or drink A. It means that A will perish very soon. The drink A will get over very soon. So it is high time for you to get it back in your inventory, so that you have the support from this. So this way we can actually have an idea about how to control the inventory given some information as you are in the sales counter. Okay, shall we proceed?
Okay, sir.
Okay, we go to the next problem. Now this is an interesting problem related to HR. The probability that you will be promoted to your office is 4 by 5. That means 80% chance that you will be promoted in the next schedule to be declared by your organization. And the probability of promotion with transfer to headquarters is half. That means both happening simultaneously. So that probability is very high, and that is half. What is the probability that you will be transferred into the headquarters knowing that you are promoted? Now you may be happy to go to the headquarters, or you may feel that in headquarters always there is someone to watch you. Wherever you are there, it is better. You will get promoted with a higher salary and you are satisfied with the place where you are working. So it is up to you how you look into it. So let us first write the event. Always whenever you have the problem of probability, express it in terms of event. That will actually help you to understand what thing you want to find out. Let A be the event that you get promotion. You get promotion. B be the event that transfer to headquarters. Now you see how we can write this. Now probability of A, it is given. It is given by 4 by 5. And B is not given, but what is given? The probability of promotion with transfer. This is one, this is another event. Promotion with transfer to headquarters. This is another event. This is B. This is A. So both you are getting, that means probability of A intersection B. This is equal to half. What is the probability that you will be transferred to the headquarters knowing that you are promoted? That means what is the probability that you will be transferred to headquarters? So what is that? When it is known that you are promoted. For example, suppose you have the meeting is going on somewhere in Delhi, where you are the headquarters of your organization, related to the promotion and transfer, etc. Now you have fitted one clerk or maybe one peon that please inform me what is the decision, or you may have a friend in the, what do you call it, your executive committee. Okay, so there you have a friend or maybe a peon. You have gave him some benefit that please inform me. So the peon or whoever you have fitted, that person is informing you. He is telling that sir, आपका promotion तो हो गया, transfer का पता नहीं. That means you are already promoted. That event, that information is already has come to you. Given that information, what is the chance of your transfer to headquarters? So you have to compute this. Now very simple. Already we know that this is A intersection B multiplied by probability of A. Be careful. What is given, that will come in the denominator here. Okay, that will come in the denominator. It is A given B, then this will be probability of B. If it is A given B, it is B given A, that's why this comes in the denominator. So this is
Sir.
Yes, please.
Please repeat again. Now, why A intersection B equal to half? Please repeat again.
So that is given in the question, that you look at the second part of the first line. The probability of promotion with transfer to headquarters is equal to half. Okay, it is given in the question.
Okay. With transfer.
With transfer. So here you have to read the line, then you will understand in terms of event. This part is very important. Not only promotion, but promotion with transfer. Promotion is given here. Your chance of promotion to the office is 4 by 5. That means 80% chance that you are getting promotion, because you have satisfied all the criteria from promotion. So highly unlikely that you will not get promotion. Very high chance of getting promotion. But along with promotion, you may get a transfer also. Whether you like it or not, that is different issue. So that is in the second part of the line. So when you read the line, you have to understand what information is given to you. Suppose by mistake someone does that, okay, probability of A equal to 4 by 5 and probability of B equal to half. Then the problem cannot be solved, or if you solve it, you will get wrong result. So you have to, this is the reason why we have considered A intersection B because promotion with transfer. Is it clear?
Yes, sir.
Okay. Now this is already everything is given to you. This is half and probability of A is given by 4 by 5. Now there's simple deduction you do. So half into 5 by 4. So that is 4 into 2 is 8 and that is 5 by 8. So 5 is a prime number, so you cannot actually cancel it. So this is how is the chance that you will be promoted to the headquarters. Sorry, you will be transferred to the headquarters given the information that you are already promoted.
Sir, in this one, if the question would be what would be the probability of promotion knowing that you are transferred, then what would be the case?
What will be promotion? Okay, promotion given that you are transferred. In that case, probability of promotion given that you are transferred. Okay, so this is now once again in the numerator will remain the same. A intersection B divided by probability of B. Now probability of B, that information is not available in my question. I have the numerator, that is half. That means I know the joint probability of promotion and transfer, that I have. But what is the probability of a transfer, only transfer, that is not provided in the question. So in that case, we cannot, given this information, we cannot compute it. So if in real situation you want to find out that, but I want to find out that, then what you can do, you may look into some previous people whom you know and find out that how many of them, whenever they were promoted, they were transferred also. Okay, so that is then how many people were transferred to headquarters. So from there you can find out the probability of B using relative frequencies. That means you know that there are in the last after the last meeting was done, the discussion was on about 15 individuals. List came out of 15 individuals, some promotion, some transfer, some promotion with transfer. So 15 individuals. Out of these 15 individuals, 3 of them were transferred from the headquarters, transferred to the headquarters. Some may get transferred without promotion. Some may get transferred with promotion. Here I want only those who are transferred. So out of total people who were discussed, whose fate were discussed in the meeting, some people may be that नहीं इसको ना transfer करो ना promote करो, इसको जहाँ है वही रख दो. So that was on the discussion. So all these things will be written in the minutes of the meeting. So if you get the minutes of the meeting, then you find that 15 people were discussed. Out of these 15 people, 3 were transferred to Delhi or the headquarters. So in that case, your probability of B will be equal to 3 by 15. This is how practically we find out the probabilities whenever actually data is not available with us. Okay.
Okay, sir.
So let us go to the next one. This is a small numerical problem. This tells that probability of A, B are 2 events. Probability of A is given to you. Probability of A by B is given to you, and B by A is given to you. Then you want to find probability of B. I think it's quite simple. Probability of A intersection B. This is equal to probability of A into probability of B given A. Okay, B given A, because A is already known, so B given A. Another this probability also can be written as probability of B into probability of A given B. So these two things are there. So I will match them now because both of them are equal to probability of A intersection B. So I can write it as probability of A into probability of B given A is equal to probability of B into probability of A given B. Now I think you have many things. You have just start replacing. Probability of A is 0.4. Probability of B given A is into 0.3 equal to probability of B. We don't know, that is what we want to find out, multiplied by probability of A given B. So that is 0.6. So this implies probability of B equal to 0.4 into 0.3 divided by 0.6. So just to find out, 4 into 3 is 12. So this is 0.12 and this is 0.6. So accordingly, you can, this is, if you multiply both sides by 100, you get this 12 and this you get 60. So this is ultimately equal to 1 by 5 because 12 5s are 60. So it's 1 by 12. So this is how we can find out the value of probability of B. I think that was easy. Let us go to the next illustration. In a survey among few people, 60 read Hindi newspaper, 40 read English newspaper, and 20 read both. So, okay. Now, let us draw the Venn diagram, because that will help me to understand the thing little bit. This is reading Hindi newspaper, H. This is reading English newspaper. And this is reading both. That means this is H intersection E. If a person is chosen random and it is known that he already reads Hindi newspaper, find the probability that he might also read English newspaper. So some information is available. In conditional probability, generally some information will be available to you. Now these are not this is an example of independent event. That means you are reading Hindi, you are reading English newspaper. You may read both also. So there is some probability. So let us write first what all things. Let age be the event that the individual reads Hindi newspaper. Hindi newspaper. You complete the sentence when you write in the exam. And E be the event that the person reads English newspaper. Now by the question what we have, 60 read Hindi newspaper, that is probability of age equal to 60. 60 means 60 divided by 100, because it is given in percentage. If you deduce, you will get it as 3 by 5. And probability that he reads English newspaper, that is equal to 40 by 100. Okay, so that is once again give you 2 by 5. Then we have like this probability of reading both, that means Hindi intersection English, that is given by 20%. So 20 divided by 100, so that will give me 1 by 5. Now we are to find that, what is we are to find? If a person is chosen random, and if he already reads Hindi newspaper, find the probability that he reads English newspaper. That is, you are to find that probability that he reads English newspaper when you know that he reads Hindi newspaper. So this is the situation. Now this will give me actually what we have here. We have this equal to probability of E intersection H divided by probability of H. This is how this formula is. Now I think you have all this information. This you have 1 by 5, H you have 3 by 5. So if you get cancelled, so this is 1 by 3. That means there is a 60% chance that an individual who reads Hindi newspaper. That means all your cases are, because you know that already he reads Hindi newspaper. So now your sample or your total number of cases is only those individuals who read Hindi newspaper, not the entire, because that information is available to you as of here. So when you start the example, you had an entire population of as many number of people are there in the sample space. But when I have introduced the given concept, that means you are now concentrated only with the Hindi newspaper reading subscribers. And then out of these Hindi newspaper subscribers, how many of them read English newspaper? That probability you have to find out. So that probability is equal to 1/3. That means it is like 33%. 33% of these individuals who read Hindi newspaper also read English newspaper. Okay. Any doubt about this?
No, sir.
Okay. Let us go to the problem. We will set this type of questions only in the exam. So try to understand these simple problems are there. A fair coin is tossed twice such that E event of both head and tail. F is the event of at most one head. So actually, in this type of things, always draw the tree diagram whenever there is tossing a coin. So a coin is tossed, so without tossing, because only twice, so I can do it without tree diagram also. Okay, so what are the first things? That one option is that both are heads, that is possible. Another is one is head, another is tail. Another is one is tail, another is head. Then there is both are tails. This is possibility. There is no other possibility when you toss two coins or 1 coin twice, whatever. Same thing only. Two coins tossed separately or 1 coin tossed twice. It's same. So this is the thing. Now E be the event that both head and tail occurs. That means probability of E, that is in the two tosses both head and tail comes. Both head and tail comes. Head and tail comes. That means it means that one toss is resulting into head, another is resulting into tail. So how many such cases are there? 1, 2. So this is equal to half is the probability. Yes, because 2 by 4. Okay, 2 by 4. So 2 by 4 is coming to be half. So this is one. Next, the probability of the event that F event that at most one head. At most one head means maximum of one head. Okay. So which is the case? Maximum of one head means either no head or one head. So this is maximum at most one head case. This is another at most one head case. This is also at most one head case, because at most means maximum one head. That means 0 head is also allowed. But we will not take this because this has 2 heads more than at most one head. So this is equal to probability of at most one head, one head. This is equal to 3 by 4. So that probability we have 3 by 4. Now we have this probability and we have to find this probability. Now in that case, what happens? Probability of, so let us first find this probability of E intersection F. That means from this case, you have to find out A intersection F. Total number of cases are 4. So let me write this 4 in the denominator. How many of them satisfy both? That means both head and tail are also there, and at most head cases are also there. That means out of these, how many of them are enjoying both marks? That is, tick mark is also there, star mark is also there. So you see, this is having both head and tail, this is having both head and tail, and both of them are having at most one head. This case will not be considered because only tail has come, head has not come. When I write union, I means both conditions should be satisfied. So you can very easily find out because of my marking that these two cases are there which are satisfying both the marks. So I have this as 2 by 4 equal to. Okay. Now let us look at this probability of F given E. Now this is equal to, if you go by the formula, this is equal to E intersection F divided by probability of E. That is the formula. This E is there not given, so E will come in the denominator. Numerator to fixed. E intersection F, just now we computed it to be half, and this is I have computed it to be half. So this has come out to be 1. That means whenever you actually F given E, that means when you know that E has already occurred, what is E? Both head and tail. In that case, F will automatically occur because these are the two cases, both head and tail, and so automatically E will get occurred because you already know that this information, that this event has already occurred. So it is certain to get the event F if the event A has already occurred, because F speaks about at most one head.
Sir, in the earlier problem,
This one?
yeah, sir. In this one, sir, the last part, PF intersection E, that one, the later part where the event E has occurred.
Event E has occurred. This one?
No, the last one.
This
PF
one.
by E, yeah. In this one, can we do this part only by seeing the this one, the H?
This one.
Yeah.
Only by seeing this one. Yes, you can do. You can do it in this way that I don't write this formula. Let me remove this formula. Okay, let us see now. This is that here what happens when I write given E, it means that E has already occurred. So your E is in this side. Your E is in this side. E event is in this side, and your what is that other event? F is in this side. This side. Okay, this side is your F. Now E has already occurred. So how many cases are with E? How many cases are with E? Total 2 cases are with E. Okay. Now when given is there, suppose what is the chance that I will break my leg if I fall down? So in that case, what happens when I break my leg? So probability of that I break my leg, Bhagwan kare ki aisa na ho. When I fall down, F at double L, this is say fall down. That means when I write this, it means that you already know that I have fall down. Now I am facing some pain, you are taking me to the hospital. Now that I have fall down, that event is known to you. their certainty has already come. Otherwise, if you don't know anything, I am going down the staircase, you are not sure whether I will fall down or I will go perfectly. But once I fall down. I think Apurva, you are asking the question.
Yes, sir.
Okay. So when I fall down, then I am shouting, Apurva, come and help me. So you have run down. So you have found that I am already lying down at the bottom of the staircase. Now this has become a certainty. That I have fallen down, that has become the certainty. Then you ask me, sir, what happened? Then I told you, oh, I cannot stand up. It's so much paining near my knee. Then you are calling an auto or taking a car and taking me to the hospital. Now what happens? When I go for an X-ray, when doctor the doctor takes care of me and look at the X-ray, then you will understand what is the context of the extent of the damage, whether I have broken the leg or simply muscle pull or muscle has got smashed or not. So now what happens? You will count with the information that F has already occurred. So here, if you look at this F given E, that means you have already know that E has already occurred. So in the denominator, how many cases are there where E has occurred? 2 cases are there. 2 cases are there where E has occurred. So 2. Now out of those 2 cases, how many of them are in support of F? That means at most 1 head. So this is one case and this is another case. So you have 2 cases which are favorable. So that's why it's 2 by 2 and that is equal to. Okay.
Okay.
So this way also you can do it. People actually confuse. They don't consider that the event E has already got. Given means that part has become certain. That the given part is certain. It is known that it is raining. You have seen outside that it is raining. Now what is the probability that you carry an umbrella? At that time there is no point saying, no, if it is not raining then the chance decreases. No, it is already raining. That information is available to you. What is the chance that now you will carry that? So that is the why our sample space decreases in size whenever we take an conditional event. Okay.
Okay.
Let us now go to the next problem. Now in this problem, what happens? You see, we have mutually exclusive and conditional event. So here conditional event is there, but there is a mutual exclusive part also. This is more practical. What happens here? We take a, suppose you are running a transport farm, and for that you are actually hiring vehicles from some agencies. You will find that in your locality, suppose you might be hiring car for some visiting some place. Sometimes you travel by your own car, but sometimes you have to hire the car also. Now you know a person who actually rents car. So you call him, not necessarily that all the cars will be possessed by him. Sometimes you may require 3-4 cars also. Long big team is going. So in that case you tell him, भैया कार चाहिए था, कितना 3 बड़ा कार चाहिए. So what happens? He may have 1 or 2 cars of that dimension. You will have it from other agencies. So here also the farm which I call and get my car, they actually do the 20% from agency D, so 20% from agency E and 60% from agency F. That means that farm there are 3 agencies D, E, F. So there are 3 agencies. So what happens when he gives the car? He uses the cars from these agencies. My farm, they use agency. So 20% cases I get a car from agency D. This is not known to me which car I am because I know the agent farm only. They are collecting it from someone else, and then 20% I get from E, and 60% I get from F. So that means this particular farm, they are in connection with these 3 agencies only, D, E, F. That's why you'll find that the total comes out to be 100%. That means from these 3 agencies. Now, the problem is that there is a breakdown in the car. Sometimes, if 10% of the cars from D, 12% of the cars from E, and 4% of the cars from F have bad tires, what is the probability that the farm will get a car with bad tire? So there is a bad tire problem. That means sometimes out of this 20%, not total 20%, 10% of the 20%. Suppose 20% means there are say 4 cars, then 10% of that 4 cars, not half of the 4 cars, 10% are having bad tire. Here 12% are having bad tire. and here 4% are having bad tires. So this is the chance. Now the question is that what is the chance that you get a car with bad tires? So let us start it very simply. B equal to I get a car with bad tire condition. Okay, bad tire. Now this, I don't know whether I get it from agency D, agency E, agency F. That information is not known to me. I just call my farm that car bhej do, he sends me. Now let us have that D is the event that I get the car. I get the car from not car, sorry, car from farm D. E is the event that I get the car from farm E. F is the event that I get the car from farm F. Okay. So this is the situation. Now you see what are the three possibilities. Number one, that means what is number one? Number one, I get a car from D, get a car from D, and it has bad tire. 2. Get a car from E and it has bad tire. Number 3, get a car from F and it has a bad tire. You may ask me that why, sir, you are concerned with bad tire? Why you are not telling about the good tire? You may get good tire also. I am concerned with bad tire because of the question, what probability that the farm will get a car with bad tire? That probability I am concerned. I am not concerned about the probability of a safe and sound journey without any hiccup. I am only concerned with the bad tire problem. That's why I have written down bad tire, bad tire. Is it clear? Now you see, the chance of getting a bad tire. There are 3 mutually exclusive cases. Mutually exclusive means if one happens, other will not happen. So I will get my car either from agency D or from agency E or from agency F. That means not simultaneously I cannot get from D and E and F. Either D or E or F, any one of them, because I want only one car. So that's why these 3 events are mutually exclusive. Along with mutually exclusive, there is also a concept of conditional probability. Let us see what is this event. This event that I get a car from D and intersection, it is a bad tire. So bad tire is B, D intersection B. Another is E intersection B. Another is F intersection B. Okay. So I have intersection D intersection B, E intersection B, F intersection. Is this point clear? If it is not clear, you tell me, I will explain once again.
Clear, sir.
Okay. Now you see, so ultimately my chance of getting a bad tire, that means my chance of getting a bad tire is equal to D intersection B plus E intersection B plus F intersection B. There is no other chance of getting a bad tire because there are no other agencies. Okay. So this is the probability I want to compute here. This event and this event, they are mutually exclusive, because if I hire a car from D, E and F automatically gets eliminated. If I hire a car from agency E, D and F gets eliminated. So any one of them will happen. Now you go to the formula of probability. That means now probability of B is equal to probability of D intersection B plus probability of E intersection B plus probability of F intersection B. So this is the probability, because why I have added up, because they are all individuals which can be added up being mutually exclusive events. Let me now erase this place so that I can get some space here. Now let us get back to the problem. Now this is equal to, now you see probability of D into probability of B given D. Why? Because agency will decide what is the chance of a bad tire, because it is written in the question. You see the chance of getting a bad tire of agency E is 10%, like that. So this is equal to plus this one also. First agency name probability of E into probability of B given E. Lastly, agency name probability of F into probability of B given F. Now you see, you have probability of D. You see there is 20% chance from agency D. So it is 20 divided by 100. I am writing the probability of D, this one. Now, probability of getting a bad tire from D. Bad tire, 10% cars of D are having bad tire. So it is 10 by 100. Plus, now come here, probability of E, second agency, probability of E is 20% from probability of E, 20 by 100 into, then it is 20 by 100. Now bad tire, 12% of the cars of E have bad tire, 12 by 100. Plus, next one, what is the chance of getting a car from agency F? Agency F, 60% from agency F. Okay, 60% from agency F. Multiplied by defective tires, 4% of the cars have bad tires. So 4%. So 4 by 100. Now you just actually multiply this. So accordingly, you will get the answer. So this is like 20 into 10, 200 divided by, I think, 1, 0, 0, 0, 0, 10,000 plus 12 into 20, 240 divided by 10,000 plus 260 into 4, that is once again 240 into 10,000. So ultimately you add it up, 240, 240, 480, 480 plus 200, 680, 680 divided by 10,000. Okay, so you will get equal to 0.1234, 0.068. So this is the probability that you will get better. That means if you are given a car and then you ride the car and go to some place, out of 100 days multiplied by 100, out of 100 days 6.8, that means approximately 7, that means 7%. That means if you go take the car from this farm and go 7% days, out of 100 days, 7% days there will be a tire problem. So it's quite high. Means you travel. So this is how this problem is solved. Any doubt? Okay, let us go to the next one. It is quite similar, this problem, and these problems are quite common because it combines actually both mutually exclusive and this one exhaustive, mutually exclusive as well as conditional event. Okay, this is, you may tell that I have this problem, that in an yarn means one basket, you may say 3 white and 2 red balls. Another yarn contains 5 white and 3 red balls. A ball is transferred from the first one to the second. A ball is transferred and a ball is drawn, and from the first hand to the second, and then a ball is drawn from the second hand, and one ball is drawn. What is the probability that the ball is white? Means ultimately the ball that you get, that is white. Now you may tell that I want to become a manager, what I shall do with ball drawing? And now you see, this is actually replicating a situation which quite often happens in our life. The two events, they are not happening together, they are mutually exclusive, but one event then one type of probability, another event then another type of probability. Okay, so these type of events, means this type of incidents happen in our life and also in several type of business problem where you can apply this. Now you see what happens here. Ultimately, you are transferring one ball from this hand to this hand and then drawing a ball. So ultimately, you are concerned with getting a white ball. Now this chance of white ball, if you transfer from here, I don't know which ball is transferred. If you transfer a white ball, here the number of white balls will increase in number. That will give you actually more chance of getting a white ball. But if the ball transfer is red ball increases here, and so the probability of getting a white ball ultimately decreases. So that concept you have to keep in mind. So let us write this, that let us first define the event. Let W be the event that the ball drawn is white. R1 event that ball transferred is red. W1 event that the ball transferred is white. Okay, understand? Ball transferred, ball drawn. Now you are to find out W. That means ball drawn is white. So W can happen in two ways. What are the ways? First is that red ball is transferred, and white ball drawn. And second way is that white ball is transferred, and white ball is drawn. So what is this event and what is this event? So first one, this event is red ball transferred is R1, and then white ball drawn, intersection W. This is what is the event. That first ball transferred is white, W1, intersection W. That means these two events are mutually exclusive because you are transferring only one ball. Simultaneously, both red and white ball cannot go. Either the ball will be red or the ball will be white. Ultimately, we are drawing a white ball. You may tell me that ultimately you may draw a red ball also. Then why you are not considering that? That is not asked in the question. Nah. In the question, they are asking about white ball. That's why we are focusing on white ball only. So these are the two events. Now you understand that the event is mutually exclusive. So what we have, probability of W is equal to probability of R1 intersection W, put it within bracket, plus W1 intersection W. So this is equal to probability of R1 intersection W plus probability of W1 intersection W. Why I have taken the probability inside like adding up? Because they are mutually exclusive. This and this event together cannot happen simultaneously. Either a red ball transferred, white ball drawn, or a white ball transferred, red ball drawn. They cannot happen simultaneously. That's why this is the case. Now, this is equal to. Now, let us look at. First, you see transfer is taking place. Then the drawing is taking place. So, I will write the probability of transfer first. The probability of R1 into probability of W given R1. Okay. Now here also you see first the ball is transferred, then the ball is drawn. So probability of W1 will come first, and then it may influence the chance of W. So W given W1. Now try to find out probability that a red ball is transferred. What is the probability of a red ball transfer? 2 by 5. How many balls are there? Total 5 balls. How many red balls are there? 2 red balls are there. 2 by 5 multiplied by. Now when a red ball comes here, how many number of red balls are there? 4 number of red balls. How many total balls are there now? That is 5 plus 8, but one ball is transferred, so it becomes 9 balls. So this is 9 balls. What is the chance I am interested? I am interested in finding out that now what is the chance of W. Now when a red ball is transferred, the number of white balls remains same to be 5. So this is 5. Total number of ball increases by 1, but white ball remains to be 5, so it is 5 by 9. Plus probability of a white ball transferred. So transfer, how many white ball? 3 white ball. How many total ball? 5 balls, so 5. How many white balls? 3, so 3 by 5 multiplied by. Now when one ball comes there, how many total number of balls? 5 plus 3 is 8 plus 1 is 9. Now how many number of white balls? After one white ball is transferred, 6 number of white balls. So it's 6 by 9. Now you just can deduce 5 and 5 cancels. 2 by 9 plus here any cancellation? No, 3 into, okay, here it's 2 by 3 and then 3 by 3. So you ultimately end up with 2 by 9. So 2 by 5. Right? Then you take the LCM, this is 45. 5 to the 10 plus this is 18. So I think it's 28 by 45. Okay, let us go to this problem. The chance of the positively reacting to a phone call in a telemarketing attempt made at random by a customer is 10%. So what happens here, you see that let A be the event, that a telemarketing is positive. Is positive means positive response. That means someone calls you that I want to sell an insurance product. You talk to that individual, not that नहीं अभी मैं busy हूँ, मुझे interest नहीं है. That is a negative. So approach of the customer was positive. He wanted to know about the product. So that is 10%. So 10% you may tell that okay, this is 10% is like 10 by 100. So that is 0.1. And then what I have, the chance that the positive call will lead up to an actual purchase, that is 7%. That means a positive call leads up to an actual purchase. So that is that means probability of A, that is given, probability positive call leads up to an actual purchase. So that A given P, that is equal to 0.7. 0.7. Okay. That means a positive call which took to an actual purchase. That means you know that the purchase was done. So the chance of that a positive call which led to a purchase is 0.7. So that probability is known. Now what is this? Find the probability that tele customer will not purchase the product. That means you are interested to find out this, like you are interested to find out not purchase, means A dash given B. That means the person talked positively to you. So sorry, this is A is the
It should
event.
be P by A.
This just 1 minute. A is the telemarketing was positive. Probability of purchase given A, that is equal to 0.7. The probability of purchase given that discussion was positive. That means you call me to sell some product. I am taking positively. Then the chance that this I will end up in purchasing the product, that is 70%. That is 7. Sorry, 7%. 0.07. 7%. Okay. So it is 7 by 100. So that is 0.07. So this is. Now you are to find out the probability that I do not purchase the product, given that it was positive. Means I started with a positive discussion, but ultimately I did not purchase. So P dash. Now this is not actually a direct problem of conditional probability. This is like this. That means total. Okay. 1 minus, because this is a complementary event. 1 minus the probability of this is given to you, that 1 minus 0.07. So the chance that I will not purchase, given that I started, that is 0.9. So this is a simple problem. That even if you start a positive discussion, it may not be a purchase. That is 0.93, because chance of purchase is only 7%. So what is the chance that I will not purchase, even if it is discussion is positive 0.9. Now last problem, let us see this. In a company, 90 employees are men and the remaining are women. Out of the women, 10% of them have children below 18 years and can take CCL, child care leave, at any instant. I don't know how many of you are the bosses in your organization. This is a means anytime you cannot rely. I cannot tell more. Okay, you cannot rely. Suddenly, lady having a child of less than 18 years may take a leave. That you cannot deny that. What is the chance that an employee picked at random can ask for a child care leave? There are 120 employees in all. Okay. Now, who can take child care leave? That person should be a lady. So total number of employees is equal to 120. 120. 90 of them are men. 90 men. Women. So men are how many number? 90. Sorry, not mean men. Sorry. Men are 90. Women. How many? 120 minus 90. That is 30. Okay. 10% of the women, 10% of the women have children below 18 years. So what happens in probability of a man that you randomly pick up an individual, that probability man is 90 by 120. So that is 0, 0 is 9 by 12, that is 3 by 4. Probability of woman 30 by 120, 0, 0, 1 by 4. Okay. Now, who will take CCL? That means obviously woman, CCL, given W, because no other people will take the lead. So that probability is given 10%. So that information is 0.1. Now, you have picked up a lady in random. What is the, or not ready, employee in random. What is the chance that the individual will take CCL? First thing that she should be an woman. And second thing that probability of taking a CCL given that that is a woman. So that is the conditional probability. So this is equal to a probability of W, that is 1 by 4, but all women are not entitled. Only those women who are 18 years. So how many of them are 18, having child less than 18 years? 10%, that is 0.1. So 0.1 by 0.4, that is actually this one is 0.1 by 4, this is equal to 0.25. So 0.25 into 0.1, so that is equal to 0.025. So there is a very small chance. If you multiply by 100, it's only 2.5%. It means if you express in percentage, that if you pick up a person at random, maybe man, maybe woman, that is not information available to me. I pick up a person at random, and the chance that that person will take CCL is actually 2.5%. If blindly I pick up an individual, the person will claim CCL, because what happens that you rely on someone, give him or her some duty, and then that person is asking for CCL. But that CCL will be valid only for women, not for men. That too having child less than 18 years. So this is the probability. That is very less chance of an employee taking child care. Okay.